Hey, welcome to learn the algorithm with me together. Today let's take a look at 1249 minimum remove to make valid parentheses. So what is this problem talking about? We'll be given a string of the right parenthesis and the left parenthesis and some lowercase English letters. And your task is to remove the minimum number of the parentheses, like in any positions, so that result in the parenthesis string is valid and return any valid string. So formally, a parenthesis string is valid if it only is like the empty strings or contains only lower characters, or it can be written like something A, B, where A and B are valid strings, or writing like this. So yeah, that made me kind of confused. So let's take an example to make it more clear. Like we have this one, the LeetCode, something like that, and it looks like LeetCode DE and then like this. And then we can have the index for each of them. And now we can see, let's just ignore the lower characters. And we can only see that there's like right parameters. If we are finding one right parameters, we also want to find, oh, this is the left parameters. So once we find the left parameters, then we also want to find right parameters, right? So that will be like a pair of them. Like for example, like this one, these are pair, and this one are pair. So that could be valid. And for the last one, because it is the single one, we cannot find any of them, any of the left parameters before it. I mean, on the left side of this one. So we have to remove this one to make the rest of it are validate. Or probably we are not moving this one. We could also like, let's go back. Like for example, let me copy some of them and so now these two parameters, they are already paired, and this two is also paired, and only the last one is left, so we can remove it. Or we can pair like these two and these two, then we only have like one left here, we can remove it. Or we can, yeah, just how we can pair any other like explanation, something like that. So probably like we have these two. So no matter which one we are deleted, the results are all accepted. So we don't care about like which one. So now our goal probably is like to like find the pair of, or probably not, yeah, find pair of the left and the right parentheses. And also we are caring about the orders, right? Even though like if we have another parenthesis here they cannot be paired because we only pair the right parameter with the left, which is just on the left side of it. So they cannot be paired. So that's impossible. So now, as usual, like we'd love to go through the whole string and try to like find all the parameters, right? Once we meet the parameters, what we are gonna do, like if we see the left parameters, and now probably we want to have a box to collect it. And we are not just like collect the parameters, we need to collect its index, because we only if we know the index, we can then use a way to remove it. So now, first of all, we will have a box to collect those index. So now the first one, the left parameters, we can just collect it, 3, because one is in the box, and then if we are seeing the right parameters, then we can check the box. Hey, do you have any left parameters? If you have, yeah, we can be paired, right? And so now we just put it in the box. So if it is the left parameters, put the index into the box, and then we'll continue to search another one, and now it's still the left, and we put into the box again, and now we find the first right parameters. And what we're gonna do, and there are probably some cases like if we already have the left parameters in the box, as we show now, right? If you already have it, we can just great. I can pair it with the fifth one, right? So, but of course, one is the box is empty, or the box is not empty. We have this kind of conditions. Like if the box is empty, or if the box is not empty. What we're gonna do for these two cases, if the box is empty, it means that it's the first right parenthesis we met, or all the previous are all paired, and like this one, he's a standalone now. So we definitely to put it in the box, right? Because for all the index in this box is ready to remove, meaning that they cannot find anyone to pair with them. They are single. So now if the box is empty, we just put the index into the box. And what if like there's something in this box? It means that there are also like two conditions. The first is if there's like because when we are seeing the left parameters, right? And now we check the box if they have like the left parameters, right? If they have one, yeah, definitely fine. We can just remove it from our box. But if they don't have, it means that they only have the left, also the left parameters. It means that we cannot do anything. So is there a way like for the first one, the 3 is the left parameters and no, I mean the right parameters, and the 5th is the right parameters? That's impossible, because if the 3 is the left and 5 is the right, the 5th will never like put into it. So it means that we only have the right, so that the box is not empty and nothing else into it has the left parameters. We have to put it into it. Or if there is a left parameters here, and if the 5th one is the left parameters but 3 is the right parameters, why we cannot like get it back, like pull out these 3 out of the box? Why? Because we care about the orders. We see the 3 first, but the 5 is come after. So since we care about the order, which means we always just like to get the last one, which is in the box. It means that this box has a properties like first in, last out, or we can say last in, first out, right? So it is a first in, last out. We care about the order. So the box can be only open like on the top to pop it out. So it means that if the 5th one is the left parameters, we can pop it out. If not, we continue to put this into the box. So we can say that if the box is not empty, and there are 2 conditions. If the top one is the left one, so the box can pop out the last one here. We can just pop it out. And now we also know that this box is a stack, right? Because only stack have the first in, last out. And if the top one is not this one, it's not the left one, it means that they are all the right parameters. We just continue to put it into the box, right? So probably we can see that like that's how we are see the parentheses, what we're gonna do. And after we go through the whole process, like this one, if we are seeing the right one, and now we can just pop it out, because actually the 3 and 5, they are all the left one, right? So when we are going to 7, we just pop it out the 5th one, and we don't have it anymore. And when we are going to the 9th position, we continue to pop it out the 3. We don't have it anymore. And then when we are going to 12, what's the condition it is? Like the box is empty again, we have to put the index into the box, right? So now we can also see that we only pop it out from a box is when the box is not empty and the top one is the left parentheses. The box can clean up the last one, but otherwise it just like no matter it is empty or not or other things, we have to put the index into the box, So we can combine these two together. All right, so now after all this, like when we are going to 12th position, we can now put the index into it. And now in this box, only have the index that we need to remove. So what we're gonna do next? Next, we need to clean out the letters on or the parentheses on that index, right? So the next thing we're gonna do is use the string builder to reconstruct the string, reconstruct the string. And how we gonna do? Because from this box, like we can only get the index from the left, from the right to left, and also it's a good thing for us to delete something, delete the letters on the string. Why? If we are deleted from the left to right, it means that when we delete it, the rest of the letters on here, their index already changed. So the index already changed, which won't match the index in the box anymore. But if we are deleted from the end, like this, like we have 12, for example, if we still have 5 or 3, when we deleted 12, the index before the 12 won't be changed. So when we are going to flip the place again, it's still the same characters. So we can continue to delete the 5. So then when we are like deleting the characters from this box, it is good because the stack is just like pop out the index from the end to the beginning. That's a good thing for us. So that's how we are solving this problem. Like first of all, go through the whole strings and find the index that we need to be removed and put it into the box. And this box is we can call a stack. And after we collect all the index, and then we pop it out because we can pop it out to delete it on our string. And when the orders like popping out is just good for us is from the right to left. So that's how we construct the string. And now based on this pseudocode, and we can move to our coding part. So first of all, we will have a stack, right? And this stack will store our index. Or probably we can call it like to remove stack, to the index to remove stack. And then we start to go through the whole string. So now first we get the character at the current index, and it will be like try at. And now how we are checking it, right? So if the current character is equal to the left parameters, we can just put it into the box. Else, if the current characters is equal to the right parameters, we can start to like seeing whether it is the box is empty or not. But especially we can see like if the box is not empty, right? If the box is not empty, and the top of it are left parameters. And when we are getting it, it's just an index, so we still have to check at the string whether it is a left parameters. So if they're left parameters, we can just put it out, and otherwise, no matter what kind of the condition it is, we continue to push the index into it, because it means that this right parenthesis cannot be cancelled out, so we have to put it into the box and ready to remove. And after go through the whole string, and we start to use the string builder. To remove this string, and first of all, we can just copy the strings here, and then start to remove it according to the index, and we can just clear out all the index in the stack. So while it is not empty, and the order is good for us is like deleting all the correct characters from the end to the beginning of the string, so the index should be still match of the original one. So now we are deleted char at the index. We pop out. After doing this, we return the string. So this is one of the results we expected. And now let's run it. Cool. So all the tests is already passed, and I believe there's no more corner case because all the characters in the strings are lower characters, as the problem said, lower case, and the strings is at least have like 1 characters, so that would be good. And let's submit it. Cool. So it passed all the test cases, and this is how we solve this problem. Like, we can use an extra data structure to help us to collect the things we want to delete, and which data structure we choose is according to like the orders or something else. So now we choose the stack. And also for this problem, the time complexity, because we go through the whole string first, it will be on, and when we are deleting it, it also, like, the worst case is every single letters needs to delete, so the time complexity will continue to be on, so it will just O2n and equals to on, and n means all the characters in this string, and the space complexity is also on. Like, the worst case is every letters needs to be deleted, so the stacks are collecting all the characters, so it is also on. And that's it. That's how we solve this problem. If you think this video helps you, please give me a thumbs up. That would be a great encouragement for me. And thanks for watching. See you at next video.